Hello everyone, welcome back to Think Lab by Saurabh. So in today's video, we are going to prepare for Agentic AI interview from beginner to advanced level. So this video is especially designed for fresher student and beginner who want to enter the generative AI, Agentic AI industry. So if you are preparing for the roles such as generative AI engineer, machine learning engineer, LLM engineer, RAG developer, or agentic AI developer. So this video will extremely useful. So we are going to cover 9 important areas. So first is the LLM and prompt engineering. Second is the retrieval augmented generation. Third is the what exactly make an AI system agentic. Fourth is the tool and function calling. And fifth is the LangGraph and agent workflow. And sixth is the memory and multi-gen system. Seventh is the production safety and evaluation. And finally, we will finish a complete agentic AI interview cracking checklist, right? So my goal is not just to help you to just memorize a definition. My goal is to help you to answer the questions using understand, explain, design, implement, and debug and defend. So this is a pipeline. So everything we try to explain through this pipeline, or you can say this formula, right? So we try to understand, we try to explain, try to design those things, and try to implement. And how can we debug, and how can we finally we defend it, right? So now we are going to start through this first thing, like first in for this PPT one. So what is the agentic AI interview roadmap, right? So the first question is, what should a fresher learn before attending an agentic AI interview? So you should think about your preparation as a roadmap. The first area is the LLM and AI and LLM fundamentals. You should understand what is the LLM. You should understand what is the token. We should understand what is the embedding, transformer, and the attention, right? And you should understand the context window. The second area is the prompt engineering. So you should know how to write a clear instruction for LLM. So you should understand the system prompt. You should understand the user prompt. You should understand the zero shot prompting, and you should understand the few shot prompting, right? And the third area is the RAG. So RAG stands for Retrieval Augmented Generation. So RAG is the one of the most commonly discussed topic in the generative AI interview. So you should understand the document loading, you should understand the chunking, you should understand the embedding, right? And you should understand the vector database, similarity search, and you should also understand how to retrieve information reach the LLM. And the final area, and the fourth area is the tools and function calling. So an LLM by itself mainly generate the information, but an agent can use the tools to perform the action. For example, agent can use the calculator, it can search the web, it can call the API, it can query for database, it can execute the code, or it can retrieve information from the files. And the fifth area is agentic AI and workflow. So here we move from simple question answering system toward that and decide what actions should be happen next. And the sixth area is a LangGraph and agent framework. So for interview, you should understand the concepts such as state, nodes, age, conditional routing, checkpoint, and the human in the loop. And the seventh is the memory and state management. So you should understand how an AI application remember the information during the conversation. You should also understand how information can be persistent for the future interaction. And the eighth area is the safety, evolution, and guardrail. So production AI is not about only the generating the good answer, it also about to generating the safe, reliable, and observable and controllable answer, right? So and finally the ninth area is a project coding interview question. So for this is extremely important for fresher. You should not only to know the theory, you should build at least 2 or 3 projects, right? And you should able to explain your project without opening your code, right? So here is my interview tips. Don't memorize a definition, instead practice explaining a particular concept, then design the solution, then implement it, and then debug it. And finally defend your design when the interviewer asks why do you choose this particular approach, right? So now we are moving to the PPT slide 2, LLM and prompt engineering, right? So now let's talk about the foundation of modern agentic AI. That the foundation is large language model or LLM. So the first interview question can be, what is the LLM? All right. So a large language model is a machine learning model trained on the large amount of text data to understand and generate the language, right? So modern LLM are generally based on the transformer architecture, One of the most important idea behind this transformer is the self-attention, right? So self-attention allow the model to understand the relationship between the different tokens in a sequence. For example, the student gave the professor his project. So the model need to understand what is his referred to. So attention mechanism help to model to understand the relationship, right? So now let's talk about the tokens. So an LLM doesn't directly process the complete sentence like a human. So text is converted into the smaller unit called tokens. A token can be represented in word and it can be represent a part of word, but sometimes as a punctuation mark. So the token are converted into the numerical representations, and this representation are called the embedding. So embedding allow for semantic information to present mathematically. Now that is the context window. So what is the context window? So context window represent how much information that model can process within a particular request, right? So this is a very extremely important in RAG and Agentic AI applications. So let's talk about the temperature. So temperature control the randomness of a model output in the system that expose this parameter, right? So lower temperatures generally encourage the more deterministic response. Higher temperatures generally allow more variations. So let's talk about the prompt engineering. So a good prompt should be clear, communicated, role, task, context, constraint, and the expected outcome format. For example, instead of saying the RAG, explain the RAG, we can say you are an AI instructor. Explain RAG to a computer science fresher. Use the simple example. Explain the pipeline step by step, and finish within the three interview questions. So these prompts give the model more structures, right? So now let's discuss about the zero shot prompting. So zero shot prompting means ask the model to perform a task without providing the examples, right? So few shot prompting means provide the example before asking the model to perform the task, right? So that is a difference here, that is important for interview. Another important concept is what is the structure output. So instead of asking an LLM for the free from the text, you can ask it to produce the predefined structure such as JSONs, right? So this becomes extremely useful when you're connecting to an LLM to software system. So now let's talk about the function calling. So function calling allow the model to produce the structure tool information that can application can use to execute the functions. So now we come to the very common interview questions here. So why do LLM hallucinate? So a good answer is LLM generally responds probabilistic based on the learned pattern. So if the model doesn't have the reliable information, lack of sufficient context or not properly grounded, so it can be generate information that sound convincing but is incorrect. So how we can reduce the hallucinations? So we can use RAG, we can provide the relevant constant context, we can also use the structure prompting, we can validate the output, we can use the tool for real-time information, and we can add the guardrail. So remember, this is the interview principle, right? So don't say the LLM hallucinate, right? Because why they hallucinate and how do you reduce them? That is the problem. So now we are moving to the slide number 3, right? So RAG. Now we're discussing RAG, so Retrieval-Augmented Generation. So now let's move the most important topics in generative AI interviews. RAG. So RAG stands for Retrieval-Augmented Generation. So that is a basic idea is simple. Instead of asking the LLM to answer everything from its internal knowledge, we first retrieve the relevant information from the external knowledge source, right? So then we provide that information to LLM. So basic RAG pipelines look like document chunking, embedding, vector database retrieval, and LLM answer. So let's understand every steps. Like first we have a document, right? Then this document could be PDF. So that they could be the Word document, they could be the website, they could be database, they could be the company documentation, or they can be some internal knowledge basis. So next, coming to the chunking. So we usually don't put the huge document into the retrieval system as a single piece. We divide the document into the smaller chunks. So this size, the size of this chunk is important design decision. So if chunk are too small, we may lose the context. If the chunk are too too large, so retrieval may becomes the less precise and consume more context. Now we are coming to the embedding. So an embedding model convert text into the numerical vector. Semantical search text tends to have embedding that are close according to an appropriate similarity measure, right? So this vector are stored in the vector database or vector index. So for example, we are talking about the chroma, pine cone, so other vector storage. So when the user asks the question, we create the embedding for the question. So then we perform the similarity search, and the system retrieve the most relevant chunks. So these chunks are provide the LLM as a context, and LLM generate the final answer. So here is a very important interview question: why don't we simply put the entire document into the prompt? So there are several reasons. The answer is there are several reasons. The document may be the too large. It can exceed the model context capacity. It can increase the token usage. It can increase the cost. It can increase the latency. So it can also provide the model with lots of irrelevant information. So RAG solve by this retrieving only the information that is relevant to current questions. So let's talk about the hybrid search, right? So hybrid search combine the different retrieval approach such as semantic retrieval, keyword-based retrieval. So this can be useful when the exact terms are important as well as semantic meaning. Now we are talking about another advanced concept is the re-ranking. So first retrieval stage may return, right, several candidates documents. So a re-ranker can score this document more precisely and select the most useful information for the final generation. So let's discuss the RAG evaluation. So we can evaluate the RAG by answer relevance, faithfulness, groundless, context relevance, retrieval quality, latency, and cost. And a strong interval question should be therefore go beyond, right? So RAG means the retrieval augmented generation. So instead of explain the RAG only, explain the complete pipelining, right? So now we are moving to those slide 4. So what makes AI agentic, right? So what exactly makes an AI system agentic? So let's compare the 4 systems. First is the chatbot. So a chatbot is primarily receive a user message and generate the response, right? Second is the RAG system. So RAG system retrieve the relevant knowledge and use it to generate the response. The third is the workflow. So a workflow follow the predefined steps. For example, step 1 retrieve the data, right? Step 2 summarize the data. Step 3 generate the report, and fourth is the AI agent. So an AI agent can be reason about the task, choose the action or tools, observe the result, and decide what to do next. So if you see the pipeline, so the it's simplified agent look like this: goal, reason, select the tools, execute, and observe and decide. So let's understand this loop. So first agent receive the goal, then it's reason about the next step, then it's select the appropriate tools, then the tool is going to execute, the agent observe the result, and finally decide whether to continue or change the direction or finish it. So this create the iterative loop, right? So now let's define some important concepts. So an agent is a system capable for taking the action towards the goal. A tool is external capability available to the agent. Memory store the information that may be useful later. A state represent the information currently maintained by the workflow. And planning to break a large objective into the into the manageable step, right? Reflections allow the system to access the result and potentially improve the approach. And tool routing just determines which tool be used first. So here is the important review warning: don't call every LLM application as an AI agent. An application using LLM doesn't automatically become an agent. So the interviewer may ask the questions, like what is the difference between the RAG and AI agent? So a good answer will be like this: RAG is a primarily focus on retrieving information to improve the generation, and agent focus on achieving a goal through decision making, tool use, state management, and potential iterative actions, right? So that is the most important question here for the interview, right? So now we are moving to the slide 5, right? Tool and function calling. So let's talk about one of the most important capability of a AI agent: tools. So what is the tool here? So an LLM can generate the text, but tools allow the application to interact with the outside world. For example, a web search tool can retrieve the current information, a calculator can perform the mathematical calculator, a database can retrieve the knowledge, a SQL database can retrieve the structured information, Python tool can execute the code, right? An API tool can communicate with another services, a file search tool can retrieve the information document, right? So now, let's understand about the function calling. Suppose the user asks, what is the weather in Delhi today? So model may determine the way that it needs a weather tools, right? So the model produce a structured tool call. For example, the tool's name will get weather, right? And argument will be city Delhi. So the application execute the functions, the tool return the result, and the result will provide back to model, and model will generate the final response. So if you see the pipeline here, so it should be flow will be like user LLM tool call, then tool executions, then tool result, after that LLM and final answer. So now comes to a very common interview question: how does an how does an agent decide which tool to use? So a strong answer will be like available tools, are described using by names, description, and input schema. So model interpret the user intent and select the tools that best match for the task. And this application then validate the tool argument, and before executing, so the tool result will be the return to the agent, and agent will decide what to do next. Okay, so now let's talk about the tool safety. Never assume that a tool is automatically safe. For sensitive operation, we should validate the input, we should restrict the permission, we should implement the authentication and authorization, we should also log the important actions, right? So, and we require the human approval. So this is especially important when agent can perform real world actions, right? So now we are moving to the slide 6. Okay, LangGraph and agent workflow. So let's discuss about the LangGraph. So LangGraph is a useful for building the structure stateful agent workflow. So this important concept is the state. So a state contains the information shared through the workflow. And the second concept is the nodes. So the node represent a step or function that performs some questions. For example, route the node, track the node, tool node, validate the node, and like the third concept is the edge. So edge define how the workflow moves from one node to another. Then we have conditional edge. So conditional edge allow the workflow to choose the different path depending on the current state or result. For example, if the user asks a knowledge questions, go to RAG. So if the user asks for a calculation, go to the calculator. If the user requests for the web information, go to the web search. So this is called the conditional routing. So here important feature is the like persistent and the checkpoint. So checkpoint, what is a checkpoint here? So checkpoint can allow the workflow to save the state so that the execution can be resumed or some kind of inspected, right? So another important concept is the human in loop. For sensitive decision, the workflow can pause and ask a human approval. And now imagine the architecture. So user write a query, right? Then it will be route, and router becomes the between the RAG, agent, web search, calculator, database, and the another tool, right? So the result goes back to agent, and the system validate the answer. If the answer is good, return the answer. If the answer is not good, then refine and try it. So this is useful architecture when you are going to explain during the interview, right? So now common interview question is, why do you use LangGraph instead of simple sequential chain? So the good answer will be like this: when the application required a stateful executions, conditional routing, loop, there is tool interaction, human approval, or complex multi-step workflow. So the graph-based approach provides the more explicit control over the execution flow, right? So one important point must be remember: be ready to draw your architecture on the whiteboard if you're going for an interview, or if they are asked about the these questions. So now we are moving to the slide 7, memory and multi-agent system. So let's talk about the memory. So memory is important because many real-world AI applications need to maintain information's access interaction. There are two basic categories. One is called short-term memory, another is called long-term memory. So short-term memory is useful for current conversation or current workflow execution. It may contain the recent message, current state, tool result, and the intermediate informations, and long-term memory is useful for information that need to persist across the future, future interaction. For example, user preference, past interaction, important facts, or application specific knowledge. So long-term memory may be stored using the database or vector database depending on the use cases. So now let's move to the multi-agent system. So imagine that we have a supervisor agent. So the supervisor receive the user request, then it's a delegate take to a specialized agent. We might have a research agent, RAG agent, coding agent, safety agent, right? And analytics agent. So it's a specialized agent has a specific responsibility, and the supervisor coordinate the process, and this is commonly called as the supervisor pattern. So let's discuss the communication. So agent may communicate through the message. They have must share the states, or they may use the share store, or the architecture depend on the problem. So very important interview question is, should we always use the multiple agent? The answer is no. So the more agent do not automatically means better system, right? So if a single agent can solve the problem effectively, adding the multiple agent may introduce the unnecessary complexity. So multi-agent system can increase the latency, cost, coordination complexity, debugging difficult, and failure point. So in an interview, don't say I will use the 5% because multi-agent AI is advanced. So instead of say I selecting a multiple agent architecture because the problem contain clearly separable responsibility that defined for specialization and coordination. So that will be the much more stronger engineering answer. Now we are moving to the slide 8. So production and safety evolutions, right? So let's move from the prototype production. So many fresher can build a chatbot. Interviewer want to know, can you build a reliable production system? So this first area is security. So one of the major risks is the prompt injection. So instruction may attempt to manipulate the model into the ignoring the system. So or they can perform the unintended action, right? So another concern is the data leakage, right? So sensitive information should be unnecessarily exposed to models, models tools, log a user. So another concern is the tool abuse, right? So agents should not have unlimited access of every tool. We should follow the principle of least privilege, right? So let's talk about the reliability. So if the real system fail, API fail, tool fails, model fail, network fail. So therefore, production agent need the like timeout, rollback, error handling, and the something a circuit break. So now let's talk about the evolutions. So how do you know whether our agent is actually working? So we need measurable metrics. For example, we measure the accuracy, relevance, faithfulness, tool call accuracy, latency, cost, and user satisfaction. We also need to perform the observability. So we should always able to understand what did the agent receive, what decision did I make, which tool did I call, and what was the tool result, how long did the operation takes. So where did the failure happen? So this is why the logging and tracking are extremely important. So we are now important concept is the human in the loop. So for high risk action, we may require human approval before execution. For example, sending an important email, deleting the data, making the financial transaction, or taking another irreversible actions. So let's discuss about the optimization. So we can reduce the cost through the model selection, caching, token optimizations, batching, and choosing the right model to take the right decision. So finally, remember this production principle: trust but verify. Always validate the important output, least privilege, measure everything, and fail safety, right? So that is the iterate continuously. And production AI is not one-time project, right? It will be the continuous monitoring. Now we are moving to the slide number 9. Final interview cracking checklist. So we have reached the final stage. So this is your final checklist before attending any agentic AI interview. So first, LLM fundamental. So you should understand the transformer, token, embedding, context window, and the model generation. Second is a prompt engineering. You should able to design the prompt structure, right? Third is a RAG. So you should able to explain the implement and end-to-end RAG pipeline. Fourth is a vector database. Understand why they are used and how similarity search work. So and fifth is the tool callings. So understand how LLM select and invokes the tools. And sixth is the AI agent. Understand reasoning, planning, tool use, state and iterative education. Seventh is a LangGraph or another framework. So understand the node is state, conditional routing, persistent, human in the loop. Eight is the memory. So understand the short-term memory and the long-term memory. Then you about the multi-agent system. So understand the supervisor architecture and specialized agent. 10th is the guardrail and safety. So understand the prompt injection, permission, validation, and human approval. 11th is the evaluation. So know how to measure the quality, faithfulness, latency, and cost. And finally, the deployment. So understand how your application moved from notebook to production services, right? After that, now we're talking about the coding preparation. So let's talk about the codings. So for fresher agentic AI role, you should be comfortable with Python. You should understand the function, class, list, loop, exception handling, basic data structure. You should understand API, HTTP request, JSON, and RAG implementations, vector database question, function calling, tool creation, agent workflow, and the basic deployment. So don't try to memorize the hundreds of library. Understand the underlying concept, right? So after that, the project preparation. So now we come to the most important parts is your projects. So I recommend preparing at least three strong projects. So project number one can be RAG application. So PDF question answering system. Project number two can be the AI agent. For example, AI agent with web search and calculator. And project number three can be advanced multi-agent system. For example, research assistant separate the research, RAG, coding, and validation agent. For every project, prepare this 7 point. Number one, the problem statement. What problem were you solving? Number two is the architecture. How does the system work? The third number is the technology used. Why do you choose those technology? Number fourth is the your contribution. What exactly did you implement? Right? Fifth is a challenge. What problem did you face? Number six is the result. What do you your system achieve? And the number seven is the future improvement. What would you change if you had more time? So this framework will help you to answer the project question confidently, right? So common interview questions. So let's quickly go through the some common questions you should practice. Question number one: what is the LLM? What is the then after what is the question number two is the what is the RAG? Third is the what do we need embedding? How do a vector based work? Fifth is the what is the difference between the RAG and AI agent? What is the function calling? How does an agent select the tools? What is the state in the agent workflow? What is the LangGraph? Question 10th is what is the difference between the short term and long term memory? 11th is when should you choose the multi-agent architecture, right? How do you reduce the hallucination? How do you build the AI agent? How do you secure the AI agent productions, right? So the golden interview formula is now I want to give you the one of the most important tips in the entire video. Don't answer technically question without only definition. For example, don't say LangGraph is a framework for build for agent. The answer will be technically incomplete. So instead you can say I use LangGraph because my application required the stateful workflow with the conditional routing tool call retrieve and the control education. So now you have to explain what it is and why you should use it and what is the problem it solve. So this is the interviewer want to hear from your side, right? So whenever possible, answer using this structured definition, then why it is needed, then how it works, a real world example, and trade-off and limitations, right? So this sequence we maybe prefer. And the important thing is how do you handle the unseen or unknown question. So let's discuss about something very important for fresher. So what should you do if the interviewer asks the question you don't know? So don't be panic, don't be immediately say I don't know anything about this. Instead of say I have not implemented this directly, but I know the understanding, I would approach like this. So then you explain your reasoning. For example, I have not implemented a production scale multi-agent system, but understand the main challenge would be coordination, state sharing, latency, cost, and future and failure handling. So this demonstrates the learning ability and never bluff. A good interviewer can usually identify you are bluffing, right? And though now we are talking about the preparation plan. So if you have only the 7 days before your interview, so use this plan. Day one, study LLM fundamental and prompt engineering. Day two, study the RAG deeply. Day three, study the embedding and vector databases. And re-ranking is day 4. You can study the AI agent to function calling and agent loop. Day 5 is study the LangGraph, state, routing, memory, multi-agent system. Day 6 build and revise your project. Day 7 do mock interview. And the final day, don't try to learn everything new. Focus on explaining what you have already know. Okay. So if you are fresher, remember one thing: don't need to know everything about AI. You need to demonstrate strong fundamental, good solving problem ability, hands-on implementation, and clear communication, and the ability to explain your engineering decisions. So the most powerful preparation formula is learn, build, explain, debug, and defend. So learn the concept, build the something with explain the architecture, and debug your mistake, and defend your design decision. So if you cannot do these 5 things, we will be much if you do these 5 things, we will be much more confident in your agentic AI interview. So thank you for watching. If you found, if you this video help you, share it your friends and who are preparing the generative AI agentic AI interview, and follow the think lab by Saurabh for more practical machine learning, generative AI, RAG, and agentic AI tutorials. So I will see you in the next video. Keep learning, keep building, keep experimenting.